Hello, my name is Keshwani. There's K-E-S-H-W-A-N-I, Keshwani. We are here because we want to prepare for the GMAT. We have been solving GMAT math problems out of this book here, GMAT Review, the official guide, the 13th edition. If you do not own this book already, purchase one immediately. You're going to need it. The book contains 230 problem-solving questions. It has 174 data sufficiency questions. We have solved every single math problem from the book. If you're interested in watching the original solutions to the problems, you will find the original solutions from day number 1 through 250. Right now, we are in the process of redoing the problems, and we are on page number 175. Please turn to it. Page number 175, problem number 163 is what we are about to do, the very last problem that you see there in the first column. Tell you what, before we actually do the problem that is given in the book, let's try this problem here. 163 is what we're going to do eventually. But before we do 163, here's what I would like you to do. Question is, what is the unit digit of 12 raised to 4 times 19 squared times 33 raised to 3. Now, if you know how to do it, or even if you're not sure of whether or not you know how to do it, pause the video and try solving it. So solve the problem. You always make a habit of pausing the video after I put something on the blackboard. Solve it yourself. You will see that you will get more out of it if you try it yourself first. Pause the video, unpause the video. I'll give you 5 seconds to do just that. Solve the problem yourself first. Try to solve the problem yourself. Okay, here's what's going on. 12 raised to 4, 12 times 12, if you were to do that, 12 times 12, what do you suppose 12 times 12 is going to end in? The unit digit of 12 times 12 is going to be 4, isn't it? And then you take that and you multiply by 12 one more time. It doesn't matter it doesn't matter the fact that it was 144. We're not interested in that part. We just want to know the unit digit. Again, you take that 144, you take that result and divide by 12. Now that represents, this quantity is going to represent 12 cube. This quantity is going to represent 12 cube. And what do you suppose 12 cube ends in a? 12 cube is going to end in a 4 times 2, which is 8. And then you take that result and you multiply that by 12 one more time, and that result is going to represent 12 raised to 4. And 12 raised to 4, whatever it is, has to end in a 8 times 2, which is a 6. So this quantity ends in a 6. The unit digit is 6. We do not know the rest of the digits, but the unit digit is 6. What about this guy? This guy is very easy. 19 times 19, the unit digit is going to be 9 times 9. 9 nines are 81. It ends in a 1. What about this guy? This guy is also very straightforward. 33 times 33 should end in a 9. 3 times 3. And you take that 9 and you multiply that by 33 one more time. And what do you suppose 33 cube is going to end in? 33 cube should end in 9 times 3, which is 27. It should end in a 7. This guy ends in a 7. This guy ends in a 1. This guy ends in a 6. And then you multiply all 3 of the quantities. We're done with this part, so I'm going to erase all of this thing. So we can do it here. We multiply all of these quantities. The first quantity, 12 raised to 4, ends in a 6. Second quantity, 19 squared, ends in a 1. 6 times 1 is 6 so far. So these two are going to end in a 6. And then you take 33 cube, which ends in a 7. So it times 7. And now 6 times 7 is 42. So the final answer, when you finish doing the entire multiplication, the final answer is going to end in a 2. And that was the question. What's the unit digit of this quantity? The answer is the unit digit of this quantity is 2. Now, if you understand this concept, and of course you do, why wouldn't you? At this point, look at the problem that is in the book and see if you can do the problem yourself. It's the exact same concept. They're just presenting the question a little bit different way. Here's the question that appears in the book. The question that appears in the book is, where can I put it without erasing this thing? The question is, what is the unit digit of number 163, is it? Just give me 1 second here. What page number are we at? I forgot. 163. Oh, now listen. It'll be better actually if you take that question that you see there on 163 and break it into two parts. Ask yourself first this question: what's the unit digit of? Ask yourself this question: what's the unit digit of 33 raised to 43? First, when you figure out this part, what's the unit digit of 33 raised to 43? And then once you have that thing, then do this part separately. What's the unit digit of 43 raised to 33? Do them separately. Do them as two separate problems, and then at the end we'll put them together. Okay? Just give me 1 second here. I'm still here. So let's do it together. I'll give you a chance in case you want to pause it and do it yourself. All right. Well, the good news for us is that they both end in a 3. They both end in 3, which means we won't have to do twice as much work. It's the same pattern. 3 and 3 here is the same pattern we're going to follow in both of them. 33 raised to 43. Let's start the process. 33 raised to 43. 33 times 33. This guy ends in a 3. 33 times 33 is going to end in a 9. That's 33 squared. Times 33. You multiply it one more time. 9 times 3. 9 times 3 is going to end in a 7. Multiply it by one more time. Or if this confuses you actually, I don't know, I don't want to take a chance of confusing. Okay? 33 times 33 ends in a 9. Times 33, and 9 times 3 is 27. 9 times 3 is 27. Ends in a 7. Again, times 33 is going to be 1. As soon as you see the 1, that's your cue, that's the end of the story. Why is it the end of the story? Because if you want to multiply that quantity by 33, you're going to end up with 3, which is what you started out with. This was 33 raised, this is 33 raised to 1, isn't it? 33 raised to 1 ends in a 3. So the pattern is, I should not have made this complicated here. So let's just stop here. So 33 raised to 1 ends in a 3. 33 raised to 1 ends in a 3. 33 raised to 2 ends in a 9. 33 raised to 3 ends in a 7. 33 raised to 4 ends in a 1. And then it's going to start the pattern again. If you multiply this quantity by 33, it's going to get 3 again. So the pattern that we have is 3, 9, 7, 1. 3, 9, 7, 1. 3, 9, 7, 1. 3, 9, 7, 1. Forever and ever. It's going to repeat the pattern. There are 4 numbers in our sequence. Now let's take a look at this thing. 33 raised to 43. 33 raised to 43 can be written as 33 raised to, see we have 4 of them. 1, 2, 3, 4. So how many 4s? The question is, how many 4s in a 43? 43 has 10 4s. So it can be written as 40 plus the 3. When you have 40, 33 raised to 40, 33 raised to 40, that's the full sequence. We are up to here. That's your 40. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, up to 40 is here. That's going to be the end of the 10th cycle. The 10th cycle is going to end at a 40. We have 3 more to go. This is 43. We have 3 more to go. So this is 40th. This is 40th. 41st, 41st, 42nd, and 43rd. 43rd is going to end in a 7. So this guy is going to end in a 7. This guy is going to end in a 7. Let's find out this guy. This is 33. This is not 43. This is 33. Again, 33. 33. How many 4s in a 33? 33 has 8 4s. 33 can be written as 32 plus a 1. 32 is divisible by 4, 32 is divisible by 4, 32 is divisible, 8 4s are 32, which means we're going to have 8 complete cycle. We have 8 complete cycle, and then we have one more to go. When we have 8 complete cycle, this is going to be our 30. When we have 8 complete cycle, this is going to be our 32nd. But we need 33rd. 33rd is going to be this guy. 33rd is going to be 3. So this guy ends in a 3. This guy ends in a 3. Ends in a 3. This ends in a 7, this ends in a 3. And what we're supposed to do with these two quantities? We're supposed to add them. And what do you suppose you're going to get if you have one quantity that ends in a 7, you have one quantity that ends in a 7, and then you have another quantity that ends in a 3, and you're supposed to add them. What do you suppose their addition is going to end in? The unit digit is going to be 0. 7 plus 3 is 0. 7 plus 3 is 10. The unit digit is going to be 0. The answer is A. The answer is A. Let's go to the next one, shall we? Number 164. Number 164. Now, just out of curiosity, if you happen to find, if you're able to find this book that I showed you, in the beginning of the video, is the 13th edition, of course, as you know it, is the 13th edition. But if somewhere you're able to find the 11th or the 12th edition in the library or someplace, look for these problems. In the 12th edition, look for number 190. Or in the 11th edition, look for number 194 on page 178 or on page 179. And do that problem yourself. Okay? Let's go to the next one. Number 164. We have x to the 4th minus x to the 3rd plus x squared over x minus 1. And the question simply is, what is the question? 164. Oh, for crying out loud. This is too ridiculous. They simply want to know what the value of this expression is when x is equal to negative 1. Let's do it here. Negative 1 raised to 4 minus a negative 1 raised to 3 plus a negative 1 raised to squared and negative 1 minus a 1. They just want to know if we know that when you have a negative number being raised to even number, even power, it becomes positive. Negative 1 times negative 1 is positive 1, and then positive 1 times negative 1, it becomes negative 1 again. It's an odd power of 3, and then it becomes positive again. So this is positive 1. This is too simple a problem. Positive 1, this is minus, and this is going to remain negative 1, and this is become positive 1. And on the bottom we have negative 1 minus the 1, it's going to become negative 2. So we get positive 1 and positive 1, which is 2, 3. We get 3 over 2. 3 over 2, that's it. The answer is 3 over 2. Let's do the next one. Number 165. Number 165. In number 165, the question is, what's the area of triangle ABC? We are told the area is 24 square feet or square yard. Makes no difference. We are told that the area of the triangle is 24 square yards. We are also told that x equals y plus 2. The question is, how much is z? Well, let's see what we can do. What is it that you're looking for? The area of the triangle we are told is 24 square yard. Why don't we make use of that information? Area of this triangle right here. Area of this triangle. So area of triangle ABC equals 1/2 base times height, 1/2 base, which is y, times height, which is x, equals 24. That tells us that x times y has to be 2 times 24, which is 48. Which is 48. But we also know that x equals y plus 2. X equals y plus 2. So let's put it in here. So x equals y plus 2, substitute in here. Y plus 2 times y equals 48. Now at this point, we have a choice. We can either open this up and set it up as a quadratic equation and make it a very complicated situation here. We could do that if you wanted to. You could write this as y squared minus 2y minus 48 equals 0 and solve this as a quadratic equation if you want to. Or you can use simple logic, simple common sense here, simple logic here, and ask yourself, where would this scenario work? This guy has to be 2 more than this guy. Obviously, it is 6 times 8. It is 6 times 8. 8 6 are 48. Our y is 6. Our y is 6. Y is right here, is 6. Our x, which is y plus 2, is 8. Question is, how much is z? Oh, what can we do next? What can we do next? What we can do is what is known as a 3, 4, 5 triangle. You can do 3, 4, 5 triangle, or you can do it out. It doesn't really matter. It doesn't take that long. But if you're able to see right away that it's a 3, 4, 5 triangle, this 6 is basically 3 times 2. This 8 is actually 4 times 2. This 8 is 4 times 2. And therefore the z is going to be 5 times 2. 5 times 2 is 10. That's all. But if you didn't see it, you could do it out. It only takes a few seconds. We know now this is 6. We know this is 8. So the z is simply going to be, z is our hypotenuse. Z squared is going to be 8 squared plus 6 squared, which is 64, plus 36, which is 100. And therefore z is square root of 100, which is 10. But it's a 3, 4, 5 triangle. What it is 3 times 2, 4 times 2, and therefore it's going to be 5 times 2. The very last question that you see on that page there, 166, I want to do it separately tomorrow. Okay? Bye now.